Hello, everybody. I am your host, Abid Samhouri, the lead of Axon Cyber Institute. This is episode number 8 of the Navigating the Cyberland series, where we dive deep with hands on demos into certain topics in the field of cybersecurity. I would like to note that this session is recorded and you can replay it later on demand. You can also access previous episodes on demand as shown on the following URL app.livestorm.co/Axon Technologies. The topic of today's session is going to be malware analysis, basic toolkits, and skill set. Before I start, please indicate on the chat that you can clearly hear my voice and you can see my screen. Okay, probably I got muted by mistake. So I was saying the agenda will be as follows. I will be talking about, I will introduce the concept of malware analysis, what it is, what the, um, what the objective of malware analysis is, and then we will talk about the necessary skills of malware analysis, how it relates to concepts such as reverse engineering and digital forensics, because these fields overlap and they have common skills, necessary skills between them. And then I will talk about sandboxes. Whenever we talk about malware analysis, the concept of sandboxes, there are different types of sandboxes. We will talk about those types, and then we will pick one type, and we will be working on one type of sandboxes throughout our demonstration. There will be labs on all the steps of this webinar. And then I will be talking about the PE executable file. There are a lot of malware types in the wild. Executable files, Windows executable files, the so-called PE, portable executable. There are, for example, Java application or .NET applications or a macro, for example, or a script or even fileless malware. But for the sake of this demonstration, of course, we cannot cover all types of malware and all types of files. We will be focusing on executable files, portable executable. And then if you would like to expand from here, you can learn .NET or Java or macro malware as well. We will talk about Packers after that, what Packers are, why malware authors use Packers, the different types of Packers, and we'll be focusing on an open source Packer that's called the Ultimate Executable Packers, the Ultimate Packer for Executable, the UPX. And then we'll jump into static analysis. We'll find out there are two types of analysis in malware. There's static analysis and dynamic analysis. I'll be talking about static analysis. What are the tools that you need to perform static analysis on a certain executable file? And then the dynamic analysis phase, what dynamic analysis is, what the tools of dynamic analysis, and what would you expect as the results of dynamic analysis. So let's jump into Okay. There is something, I'm not sure why it's happening that I get muted after a while. Either I clicked by mistake or, okay. So I was saying what malware analysis is. It's a process, it's a methodical process to unveil and discover how a piece of malware behaves and is acting on a system. Whenever there is a malware, we would like to know whether it is creating files, deleting files, or modifying files. So basically, we want to know any interaction with the hard disk, with the file system itself. We also want to know the interaction with the registry. Is there like certain keys that have been created in the registry, or keys that have been deleted, or values that have been modified? Is it hiding a payload or a file or executable on the registry? Because sometimes you can hide like a binary file inside the registry, and that would make it invisible from the file system. We also want to know what types of network traffic the malware is doing, which domains it is contacting, what DNS queries is trying to resolve, whether it downloads files or upload files, whether there is command and control, like it's talking to a central system and then taking actions or tasks from a remote system. And then finally, we want to know if this malware is propagating inside the network and how it is propagating. Is it propagating through network shares or external drives? Is it propagating through network exploitation? So malware analysis unveils all of these, unveils the characteristics of this malware. Now, then why do we do malware analysis? What is the purpose then of doing this, of knowing all of that? Well, initially, we want to do malware analysis so that if there is any infected system out there, and we want to recover this system and we want to remediate this system, we have to do malware analysis. And once also we do malware analysis, we are able to even defend other systems from any future infections. Now, this was this was the objective of malware analysis in the past. However, nowadays we have what we call threat intelligence, and the threat intelligence are like constant online or on the cloud databases that have signatures of all publicly discovered malwares, and then people would subscribe to those threat intelligence feeds, and then they update their own scanning engines or their antivirus or their EDR. So from malware analysis, we develop signatures of the malware. We develop what we call indicators of compromise, IUCs. So in short, after doing a malware analysis, you would come up with indicators of compromise and signatures of the malware, and then you might update the threat intelligence feed, whether you subscribe to, or you can simply export it and upload it online for other vendors to use. And then, of course, this can be used to remediate systems, to delete any damage that was done, and to clean the system from this malware, and then, of course, prevent future infections. So, as I said, there are different topics that overlap with malware analysis. There is reverse engineering, and there is digital forensics. And those three somehow overlap. And usually malware analysis, people who specialize in malware analysis, they also specialize in one of those other fields, like either reverse engineering or digital forensics, because the skills overlap, and not only the skills, even the knowledge overlap. For example, all of them require you to know deep how the operating system works. All of you require you to know how an executable file is structured, for example. So reverse engineering is a process of getting like a clean program that is not a malware and that is like authorized and that is official, like officially developed by a vendor, and then you try to discover vulnerabilities in it. And usually this is done through a process that is called disassembling and another process that's called debugging. These are the two main phases of reverse engineering. Disassembling is you try to work your way from the bytecode or from the binary or the machine code, and then you try to get the assembly code, and from the assembly code you try to get the higher level source code. And one common tool for this assembling is IDA, interactive disassembler. And like, of course, there is a free version and commercial version. And debugging is a process of executing the program in real time while monitoring all its behavior at the machine code. So you try to watch and you try to check how each machine instruction is being executed in real time, and you would see the subtract, the add, and all the subtle machine instructions, along with any memory access and to which address it is being accessed, and all the file interaction and all the like interaction with other external DLLs or other files, and the way it interacts with the file system, and so on. But in reverse engineering, you do not work with malware. You work with real programs, with the clean programs. But of course, if you specialize in reverse engineering, the skills over there will help you advance your skills in malware analysis, because after all, a malware is also a file, is also a program that's executable. And this, you can add disassembling and debugging to your malware analysis, and you would even get a clearer picture of what the malware is doing. The other topic is digital forensics. And digital forensics, they try, like, if there is a system that got infected and we do not know which malware that has been planted there on that system, we would like to figure out what happened. So everything is oblivious to us, and we would like to uncover what happened. And there are typically two major tasks that are done in digital forensics. One of them is disk image analysis. You would acquire like a full image of the hard disk, and then you would analyze everything that is on that hard disk, from the boot sector, for the master boot record, all the way to all the files, to all the sectors, and so on. And you would uncover files, you would uncover data, you would even uncover like files that are deleted in the operating system itself. And then the other phase in digital forensics is RAM analysis or volatile analysis, where you would like dump the entire RAM in a file, and then you would analyze what the RAM, what the content of the RAM at the time of the infection was. Now, again, in digital forensics, you are dealing with so many files. So you're trying to analyze so many files on the hard disk and on the RAM, so that you would uncover which file or which piece of code is actually the malicious one. In malware analysis, you have already got a certain program. You have already got the file, you have already got the executable, and you already know that this is a malware. It's not that like you have a program and you don't know whether it's a malware or not. You already know, you're already sure this is a malware, and you would like to analyze to uncover how it behaves. And there are two phases here. The first one is the static analysis, and the static analysis can correspond to the disassembling and reverse engineering. And then we have the dynamic analysis of malware analysis, which corresponds to the debugging phase in reverse engineering. In the static analysis, we examine the PE header. The PE is the portable executables. We try to examine the headers and also the sections. And from the headers and the sections statically, without executing the program, we might get a great deal of information about the malware. And then the second phase is the dynamic one, where we actually execute the file, the malware, in a sandbox, and then monitor what it changes is happening or are happening on the operating system live. So let's talk about sandboxes now. A sandbox is a dedicated system. You always, whenever you want to do malware analysis, you have to start in a sandbox. You cannot simply get the malware and you try testing it on your machine or on production environment. You have to put it on a sandbox, a machine that's fully isolated. And of course, it's not all, it's isolated. Whether it's VM, it has to be isolated from your host machine, and it has to be even isolated from any network around you. It has to be isolated from the internet. So it's fully machine that is dedicated for malware. You do not care if it gets infected. You can simply, once you finish your analysis, you can wipe out everything and re-image the whole thing, or you can return to a previous image that is already stored. And the sandbox has to have certain tools installed in it. We will talk about some of these tools. There are different tools, and some tools are even redundant. And literally, there are tens and hundreds of tools that you can equip your sandbox with. And then finally, you need to have something we call network simulator or Fakenet. And the purpose of a network simulator is, imagine your malware would like to connect to the internet to resolve certain DNS, to download certain files, and so on. And if the sandbox is fully isolated, then once the malware tries to resolve a certain DNS or a domain, and then it figures out it is disconnected and there is no resolution, it may not continue execution. And this is bad, because we want the malware to continue execution to monitor everything about it. So a network simulator is a software that you would install on your sandbox, and then it will respond with fake answers to any network queries that the malware is doing. So if it sends like a DNS query, the network simulator would respond with the DNS reply. So at least it keeps the malware going. If it tries to access a certain URL, it will respond with a bunch of HTML file, for example, and so on. And we will talk about a certain fake network, from where to download it and how to install it, and we'll see a demo on it. Now, there are different types of sandboxes. The first type is simply developing your own. And this is like a manual sandbox and an offline sandbox, which means like you create it offline, it's not on the cloud, and it is manual, meaning you have to run each tool separately. Like as you can see here on the screen, I have a screenshot of my sandbox where I have all of these tools. And as you can see, there is like Process Explorer, Process Monitor, TCP View, exe info, IDA free, proc dot, and so on. So you equip it, you install the tools manually yourself on a VM, and then when you do analysis, you run each tool separately, and it's up to you which tool to use at which order. But just for consideration, you have to install, of course, Fakenet from this URL, practicalmalwareanalysis.com/Fakenet. You can download it, and you can see a shortcut. I have it on the image over here. And if your sandbox is a VM, make sure it has host-only adapter, okay, so that you isolate it fully from the external world, and make sure you disable real-time protection. Either you disable it at least temporarily, or you can even disable it permanently from the registry. So this is the first type. The second type is where you would use like an offline, again, something you downloaded, okay, but it is ready-made. Somebody has already developed the whole VM for you. It has all the tools there, so you will not like install each tool separately, but you get the VM, and like everything is there. And one common sandbox is the FireEye Flare. The FireEye Flare is a VM It's a Linux distribution, just like we have Kali Linux, that is Linux distribution with so many tools for penetration testing. FireEye Flare is a distribution, Linux distribution with so many tools that is used for malware analysis. So instead of you worrying about like dependencies, updates, and so on, you simply download this whole thing, and then it is fully on your network. It is fully on your sandbox and your machine, and then like you simply start running the tools. And of course, the URL is shown on the slide. It's at github.com FireEye Flare VM. Then we have got a cloud-based automated sandbox. Now, automated sandbox, this is the third type and also the fourth type. The third type and fourth type are automated. What does automated means? These are sandboxes that you do not control the process of analysis. You simply feed your executable, your malware executable into the sandbox. The sandbox would run it itself, and it is already pre-programmed of how to analyze the malware. And then once it finishes, it will simply generate a report with all the analysis that you need, with all the like network traffic interactions, file system interactions, process interactions, registry interactions, and so on. And it will give you a report. You will not run any tool inside this sandbox. You will not do any manual thing. You simply feed it the software, and then you get a report. And one such cloud-based automated sandbox is any.run. There are others, but any.run is a very sophisticated one, and we will see a demo at the end on this one. You simply you upload, you have to create an account, you upload your malware, it runs it, and then it will give you a very interactive report. And then finally, we have automated sandbox that is offline, something that you can download on your machine, on your laptop, and it's not cloud-based. And one popular of such sandboxes is Kakubox. And Kakubox works just like any.run, but it is installable and downloadable locally on your machine. Again, you feed it a file, it does its own thing, and then it will generate a full report of what this malware is. So, since we're gonna focus on PE, portable executable, we need to understand few things about portable executable file. Any portable executable file is divided into two sections, the headers, or two parts, the headers part and the sections part. The headers part, as you can see here, is composed of multiple headers, and all the headers do is to instruct the operating system of what this file is. Like every file must have a signature that indicates how it is running or how it is opened by the operating system. And for executable files, everything is in the header, okay? And there is like a DOS header. This is to be compatible with older, or to be consistent with older file structures pre and T. And then we've got the PE header, which are also called the NT header, and then optional header, which is not really optional, but very important, but it includes additional data. And then we have section tables. The section tables would point to the tables or to the sections which contain the actual program. Because the green side in this image, the green side is where the actual code and the actual data is. And the sections table would point to that. And then we've got the import address table, and the import address table would contain addresses of all the function calls. Like if your program would talk to a certain external DLL or would like to use certain functions or APIs from either the system or from other files, everything gets resolved, the pointers are stored in the import address table. And then we've got these sections. And the program itself is divided into sections so that the system would understand where the code is and where the data is. And there are different types of data sections as well as different types of code section. For example, .text is always the code section. It contains the machine instructions itself. Sometimes it's also called .code. And then .data, .rdata, .edata, and idata, these are the data. These are like the variables, the initialized data, the uninitialized data. We will see some of them later on. Finally, we have the resource.rsrc. This is also very important. We're gonna see how malware sometimes utilize this part. The resources contain like additional, everything that doesn't fit above, it fits in the resources. This could be the icon of the file or additional embedded files or like simply signatures of the file and so on. So if we dive deeper now into the PE header and the DOS header, we find that the PE header is further divided into so many sections, okay? I'm not gonna go into each section in here, but there are a few important ones to note. The first one is the signature in the DOS header. Every PE executable file has a certain signature, and that is hex, as you can see here, 5A40, 5A40, and this stands for MZ, okay, the ASCII letters, M capital letter and Z capital letter. So by itself, this by itself is a great indicator that the file is executable. And then in the PE header, we have time date stamp. This is the time the code was compiled. It is not the code, it's not the time of the creation time or the last access time, the time stamps that we know of. This is the compilation time. And then address of entry point. The address of entry points points to the main function. If you know some programming or if you have like background in programming, you know that there is always in every program a function that is the main one. And that is the address of the main function is the entry point. It is on that address the operating system would start executing the first instruction of the executable. And then the import address table, as you can see here, this is also very important because from here you can know all the function calls and from other DLLs and from other files. Let's talk about Packers, because Packers are also very important when it comes to malware analysis. Sometimes malware authors use a technique called packing to evade detection and to evade analysis. And packing is simply compressing the code or encoding the code or even encrypting the code so that it doesn't become easily readable or easy for analysis. And as you can see here in the image, if you have the original file with PE header and code and data, if you run it through a packer, what's going to happen? The entire program is going to be obfuscated in a way and then inserted into another program with another PE header. And there is always an additional section that is the unpacking code. So when you start executing this program, the entry points will not be inside the packed program. The entry point will be the unpacking code. And then the unpacking code will do the job of decompressing, decoding, or decrypting the packed program in memory. Okay, and there are ways to know whether the program or the malware we're dealing with is packed or not, and we will see some of those some demonstration on that. A very common and open source packer is the ultimate packer for executable. or UPX. This is open source, and it's a simple packer. It relies on compression. It doesn't do any encoding. It doesn't do any encryption. It does compression. So it takes the whole executable, it compresses it in a new directory, in a new program file, and then it will add a decompression stub or a decompression function that decompresses the original program in real time. You can download it from upx.github.io, and you can use the command line. UPX is the command line to pack program.exe, for example, and give it the output file name, and then you can use the -d for decompression. I will come to the packing later on, and I will show you an example of how to unpack a certain program in a while that is packed. But first of all, before actually we unpack a program, we have to know whether it is packed or not. Like if I get a piece of malware, is it packed or not? And this is the first step I need to know. I need to profile my executable file. I would like to know what type it is, what the headers are, and whether it is packed or not. Simply basic signatures of the file, whether it's a .NET program, whether it's C++ program. And for that, I have specific tools. Basically, we're gonna look now into 3 tools: the file tool, the exe info PE tool, and the thread tool. And in addition to these, your sandbox must have, you always need to have a hashing program to hash your malware and get the hash. So maybe if you search online, you might find like other people have done certain work on that, and its hash is already published. And as we can see, I'm gonna like demonstrate on some educational malware with hashes, and like you can see on VirusTotal, for example, some antiviruses already have signatures of that file. So a good tool for hashing is Compute Hash. So let us start with the file tool. I'm gonna now fire up my VM over here. And we'll be like profiling two malware, two real malware. This is my Windows 7 sandbox. I have installed like a bunch of tools over here for malware analysis, and I have 2 malware here. One is called Budget Report and Financials Excel. These 2 malwares are like, they are real malware provided by Pluralsight company, and we're gonna work on them throughout this demonstration. But also I would like to note that this whole VM, I have already taken a snapshot of it. So every time I do dynamic analysis on one of these malwares, I will have to revert back to a pre-configured snapshot so that I clean the system to a clean state. So this is Fakenet. I have already run it. It intercepts any network traffic. Okay. So this is the program file. Okay, you can download it online, and so I'm gonna profile, I'm gonna check what these 2 files are. They look like PDF and Excel. However, are they really PDF and Excel? File, the program file should tell me something else. Okay, this is file, and then I'm going to copy both of these to the desktop so they become easily accessible. And then I will start with the first one. So I will not use the shortcut. I will simply use the original one. Let's see. To go to the original file instead of using the shortcut. So okay. So as you can see here, simply this program file would tell me the signature of the executable that I already have. And as you can see here, all is telling me that this is PE, so it is an executable file indeed. It is 32-bit, as you can see here. Okay, it's made for Intel, and it's a GUI file, okay, graphical interface for Microsoft Windows. So even though it looks like a PDF file, it's actually an executable file. I can do the same with the other malware, and the result would be identical. So I've already here ran both of them, and both of them, the financials EXE and the budget EXE, are portable executable for 32-bit for Microsoft Windows, and they are graphical user interface, or they claim to be graphical user interface, because as we're going to see in a while, this is a bit inside the header that indicates whether it's a graphical interface or not. And even though those two malwares are not really graphical interface, they do not pop up any windows, but the bit is made to look like graphical, like a GUI file. The second program, aside from the file, is the exe info PE. This will give me more information about the files. And one beautiful thing about this tool is that it can tell me whether it is packed, whether the malware is packed or not. As you can see here, it can tell me this is not packed, or the other one, the other image, it tells me it is packed, and it can even tell me which program is used for packing. Like in this case, UPX is used and tells me how to unpack it. So let's do this very quickly. So the tool is exe info pe. This is the one. This is the tool, and I can simply put the first one, the budget report, and then it tells me it is not packed, and it is C++, mostly C++, compiled probably by GNU compiler. So it's C++ compiled by GNU. So it's compiled in Linux for Windows. While the second one, the financial one, it tells me it is packed. So it tells me here it's UPX. It's using UPX for packing, and you can unpack it using this command. So if you download UPX over here, okay, you can unpack it by typing UPX -d and then give it the file name, and then you will get the original one. And I myself have already unpacked it using UPX over here, and as you can see, there is a big difference between the two. The packed version is 43K, while the unpacked version is 56K. So the packed one is compressed. That's why it is shorter. And as we can see in a while, there will be some differences in the sections and in the headers, and even the strings inside them are different. So let's move on now to a third tool. A third tool is called thread. Now, thread is also a file identification tool, but it differs from the file.exe in that a thread utilizes a database that is more intelligent. So instead of relying on a static signature on a file that can be modified like the MZ, it tries to analyze the whole program, and it creates a pattern. It looks on the pattern of the program rather than a static signature. So let us use thread here and try to see. So I'm gonna give it the first one, the budget report. Okay, this is causing trouble. Let me reopen it, CMD. Okay, thread. Okay. And then budget report. Okay. As you can see here, the budget report, since it is looking on a pattern, it will give you like different possible answers with a guess, okay? So it's telling me like 44%, there is 44% chance it's a Windows 32 executable, Microsoft Visual C++. 23 is also Microsoft Visual C++ compiled executable. So mostly the first two are identical, while those less than 10 are like very, very rare and mostly incorrect. So we can rely on the first two. This is indeed executable, 32-bit executable. Now, similarly, I can now do the same for the second one. And if I check the second one now, which is the packed version, look at this. 54%, it is UPX compressed Windows 32 executable. And 13% is DLL. Now, there is high chance, of course, 55% is more reliable, and it is UPX. So it confirms what I got with the exe info PE tool. Now, let us do the same for the unpacked version after unpacking it, which is this one, and let's see what we get. The unpacked version, 40%, nearly 40% is Windows 32 executable, Microsoft Visual C++, and there is a chance 33% is exe Yoda cryptor. Yoda cryptor is another packing algorithm, okay, but it's much, much more complicated than the UPX. So if this is true, if this is like, if the answer that has got 33% is true, that means this malware is double packed, meaning it was initially packed using Yoda packer, and then later on it was packed using UPX. Okay, maybe we can discover this later on, but it's good to keep this in mind, that sometimes a malware can be double packed and could be packed twice using two different algorithms to complicate things. So after having done this this file identification using the three tools that we have got, the file, the thread, and also the exe info, the exe info, now we will do something that's also very important, and that is easy to do, which is to extract embedded strings. ASCII strings in the source code remain the same after you compile and you get your final exe. They are not changeable, and you can extract them. And those strings can give you a lot of hints and can give you like a lot of ideas about what the program is doing. And like the strings can include like domain names, can include like HTTP headers, for example, that the program is using, can include file names, API calls, registries, etc. So, and sometimes it's very easy to get the strings by simply opening the whole exe using Notepad. Now, this is of course not neat. Anyone who has done so, like, you will get a lot of unreadable things. But luckily for us, we have got like nice tools to extract the strings clearly for us. The first one is strings, and this tool is part of sysinternals. Sysinternals is a package of so many tools, okay? And it's very, very powerful for debugging, for security analysis, for reverse engineering, for even troubleshooting, network troubleshooting, and system troubleshooting. And one of the tools inside it is strings. And any sandbox must have such package. And as you can see here, I have already installed sysinternal suite as a whole, and it includes all of these tools, more than 100 tools inside it. And the strings is simply over here. This is strings. There is one for 32-bit and one for 64-bit. Now, we will not use this tool now. There is another tool called BinText. It's a graphical interface, and it is easier to use. So let us use that one instead of the strings. So this is BinText, and I can simply drop my file over here, and then I will get a list of the strings inside it. Now, this string, the first one, this program cannot be run in DOS mode. This is always a static string in every executable file. Now, it can be modified by a developer, but by default, it's always there. Now, you can see here the sections names, and if I scroll down, I can see a lot of, now, of course, you're gonna run into some garbage, unreadable strings, but then you might run into some readable strings, like this might be base 64 encoded strings, and these are, for example, processes which the malware is talking to, and some names, processes names that are used. And of course, I have something related to browser and refresh content for a browser, so probably it interacts with the browser. And I can see here Mozilla, so probably if it is a malware, either it's doing something to Mozilla, intercepting Mozilla, doing like a spyware, or it could be deleting the program. We do not know exactly what it does. It has like some, this is a registry keys, as you can see, current control set services, and so on. You can see like software, Skype. It tries to find, like, maybe it interact with the Skype, or try to kill your Skype or infect your Skype, Chrome, Internet Explorer, Opera, Firefox. So it's looking for everything related to web browsing, Google Chrome. And then if I scroll down, I see like APIs, ICMP create, ICMP close. So probably It performs some ICMP traffic, get host by name, it does DNS resolution. These are all related to TCP/IP interaction, all of these functions. It also does something to Wireshark. It searches for Wireshark. It has autoruns as well, some registry keys. This is like part of an HTTP header, for example. So probably, as you can see here, HTTP, HTTPS. So probably it sends some HTTP packets over the network. Okay, exceptions. These are typical programming APIs. Let me scroll down. I can see even functions related to registry close key, create keys, delete values. So it interacts with the registry, it interacts with the file system, it copies files, create directory, create events. Also some network. These are all functions. So sometimes I can find a great deal of data just by looking at these strings. Of course, if the strings is if sometimes the strings are hidden or encoded using base64, and you can spot this by finding the signature of base64. Whenever you find a signature like this, the entire alphabet, capital letter and then small letter and then the numbers and then all the special characters as one string, that means the malware is encoding some strings. Or sometimes you can see equal sign or double equal sign at the end of string. That means also it's an indication that this is base64. And of course you can decode it either by using a tool or you can upload it online and decode it. Focus always on very important things. Find the strings related to persistence, like run or run once, or start menu path, so it drops itself in a start menu. Find encoded and base64 strings. Try to find URLs and domain names. Like be watchful of APIs and DLLs and system calls. Now, after having extracted the strings and analyzed the strings, next thing is to actually investigate the PE header itself. And as I said, there is the time data stamp, which is the time the program was compiled. There is also a bit that indicates whether this program is a GUI or not. Of course, we need to investigate the import address table and see the functions and APIs, and then the sections table. And for investigating the PE header, we have got a tool that is called PE Studio. And of course, we have got the CFF Explorer, but we will focus here on PE Studio. And I have it over here. I'm going to open, this is PE Studio. This is one of the most powerful static analysis tool over there. And I'm going to open my malware. Okay, this is my first malware. So I'm going to put it here. And then I'm going to open another one next to it for the second malware that is packed. This is the second malware, just to show you guys the difference between the sections and between the packed version and the unpacked version. And then I'm going to open a third window for the unpacked version of the malware. And we're going to look into some important things. This is the unpacked version. So first of all, PE Studio will dump the entire header. This is the DOS header, okay, and the actual file header, okay, and in here you will see the timestamp, okay, like our first malware was compiled in 1998. Now this looks suspicious, and PE Studio with its color scheme has a way of telling you if things are suspicious or not. If it is red, that means it is an indication. It is it's a risk indication. It's a high risk indication. If it is orange, it's a medium risk indication. And if it is simply black, that means it is normal. So we find here that the timestamp is orange. That means there is something suspicious. It's very hard that this program was compiled in 1998. So probably the malware author has intentionally modified this to hide itself or to make itself look very old. The program is very old. And then we have sections. This is the actual sections of the data and the code. Okay. Now, our first program that is unpacked has how many sections? 1, 2, 3, 4, 5, 6, 7, 8. .text is the code. And then we have data. And these are also for data, but different types of data. There's like initialized data, uninitialized data, and so on. And BSS is also for data. And iData for import data. And then we should find at the end the resources section. This is also very important. Now, a few things we need to look at when we look at the sections. First of all, are their names standard? Do they have standard names like .text, .data, .rdata or not? If they have standard names, usually it means it is not packed, okay? If we look at the packed version, their sections look different. They look UPX0, UPX1. And this is a direct hint that this is packed using UPX. If we look at the unpacked version over here, we also see .text, .data, .resources. 3 sections only. So they look, at least it is not packed. Okay, but there are other problems in here we're going to see in a while. The second thing we need to look at the sections is their file permission, their permissions, whether writable, executable, and readable. Okay, read, write, execute. As a rule of thumb, always remember something, that any code section, any section that contains executable code, it has to have the permission executable, okay? However, it should not be writable. It should be read only. Whenever it's executable, it should be read only. Data section, on the other hand, can be writable. However, data sections should not be executable, okay? Whenever you find a section that is executable as well as writable, this should be it should raise a flag here, okay? It should raise a flag, because in a typical program there is no need for a section to be writable and executable at the same time. If it is code, it has to be written at compilation. But sometimes malware, what they do, they create such sections so that they can unpack or uncode certain data and put it as if it is data and write it as if it is data and then execute it because it is not really data, it is instructions. So we have to look for such a flag, write and execute. And on the first one over here, we do not see any of that. Everything that is writable, this is writable, for example, but not executable. Writable, not executable. This one here is executable, but not writable. So it looks this flag is not there. On the other side over here, I can see both of these sections, UPX0 and UPX1, are both writable and executable. Both writable and executable. And this is also, this is bad. Okay, at least it's a red flag. Something else I want to note here is, as you can see, PE Studio is flagging the entry point in here. The entry point is very strange. The entry point, usually the main, has to be on the first section. Okay, so why is it the program jumps into the second section before the first section? This is also like it's a red flag. Since this is packed program, it's very natural, it's very normal that the program would start on UPX1, so that this is the packing code and it packs whatever hidden inside or compressed inside UPX0. Okay, so let's move on. Another thing that PE Studio would give me is the list of libraries or the DLLs which my malware is interacting with. And this is a list. And PE Studio has a way of flagging certain DLL file. Like the first two, these are related to networking. Now, of course, any program, legitimate program that uses network operation, PE Studio is gonna flag these, but it doesn't mean it's always harmful. Okay, just a note to keep in mind. So I have some DLL used for networking, and then I have DLL for shell execution, okay, and then for user and kernel. For this one, for example, the libraries, again, I have for socket and kernel and shell, and for the last one, almost similar, not a big difference. Then I can jump to the import. The imports, these are the API, the function calls, the import address table, okay? These are the function calls used by my program, okay? And I will have to watch for a few important ones, and I have listed them over here. Okay, functions, APIs or import that interact with the registry, like create key, delete value, set value, functions that interact with the file system, copy file, create directory, write file, or functions that works like with the processes, get the proc address, it load the library, shell execute, whether it executes like command on the shell, networking functions, and so on. And I can see a list of imports over here, and I can see many of the functions here, like registry manipulations are already listed here. And as with the libraries, PE Studio can flag some of these APIs or some of these imports. And if I would like simply to see only the flagged ones, I can sort with blacklist over here, and I can see all the flags, all the flagged calls that the program is doing. Okay, and I can see like shell execute, there's shell execute, terminate process, set thread context, open process. It will like create process, get host by name. This is for DNS resolution. Registry delete, it deletes a value in the registry, and so on. And then I can see that even PE Studio extracts a string for me. So instead of even utilizing the other tools for string analysis, PE Studio has already done so for me. And these are the strings. Like I can see post, connect, send. These are all for networking. I can see the base 64 that I've seen earlier, the Skype. I can see the registry keys and hives, current version. I can see the call, the DLL. They are embedded as strings.com, Google Chrome, Internet Explorer, Firefox, the interaction with the browsers, which is very similar what we got with the Ben text. and also, of course, all the API calls and the libraries. And I can scroll down and see what's over here. Again, registry authorized application. It does something to this registry. It enumerates disk. Again, base 64, some base 64. I can see a string. The oldest and the strongest emotion of mankind is fear. And the oldest and the strongest kind of fear is the fear of the unknown. Okay, some wise malware author. Again, HTTP, and so on. These are also very important. So I can jump directly into PE Studio whenever I would like to analyze an executable. Instead of doing all the previous steps that I have done, I can simply, the first step I do is I open PE Studio and I get everything statically from here. Okay. So let's jump to the next topic now, which is dynamic analysis. So that we save some time. We have already seen, okay. The last part I would like to mention about the PE Studio is from all the flags that have got that PE flags inside the strings and import and libraries, it evens put them in the first section here, indicators. So the indicators would actually tell you the severity level that have been found inside this executable. Like there are 83 blacklisted strings. Okay, there are 2 flagged libraries. Okay, and so on. So it can tell you the problem with these sections. So if I open the second one, for example, here the indicators, like 17 flagged strings. There is something in the resources that is Russian. In the resources section here, if you remember, I mentioned the resources used for icons and stuff, and sometimes malware hide their own program, like they might have a Word document, PDF files. The languages, sometimes if you see a language that is not a neutral or English, this could even indicate that it's a suspicious file. So probably the malware author was compiling the program in a laptop that has the native language Russian, and then the PE Studio would flag this as risky. So, of course, PE Studio has a lot of features, and I do encourage you to experiment with it. It has even a section for VirusTotal. So instead of uploading your program to VirusTotal, it can even provide you with all the antivirus that flag this program. Let's jump to dynamic analysis so that we finish early. Like maybe we need 15 to 20 minutes more, and then we finish this webinar. When it comes to dynamic analysis, in dynamic analysis, we want to execute the program in real time and monitor the behavior and figure out and find the changes done to the system in real time. And we'll talk about 3 tools here. The first tool is RegShot. The second tool is Process Monitor. And the third one is ProcDot. RegShot is simply a simple tool that takes 2 snapshots of your system. Okay? And you take the first snapshot, and then after a period of time, whenever you would like, you take another snapshot using the same tool, and then it compares the 2 snapshots, and it tells you the difference. So it tells you what was modified, what was added, and what was deleted, whether on the registry or on the file system. It doesn't tell you who made the change, like this process deleted this file or this process deleted this registry keys. It simply tells you this was changed, and that's it. Now, of course, this is incomplete. That's why we need to complement this with ProcMon. But at least it will give us some hints. It will give us some hints. So you take the first shot and then the second shot and then compare. Let's do a quick demo in here. So I'm gonna close all PS Studio. Okay, I have Fakenet running. This is very important now. And I'm gonna open the rig shot. What I'm gonna do now, and I can, first of all, I can save the output as HTML or plain text. Let's keep it HTML. I can enable file scan. Okay, so I'm gonna remove this one. And I would like the output to be the dynamic over here. So I will take a snapshot, the first snapshot, then double click the budget report, okay? And then stop and take another snapshot and see the difference. Let us do that. Rig shot. It's taking now a snapshot of the system. 7 seconds, 8, 9, 10, 11, 12, 15 seconds, 16, 20. Okay, done. So let us run the budget report. I'm gonna run it as administrator, just in case there are higher privilege tasks, so that it does all of its tasks. Okay, I can see it tries to communicate to the internet and to send some HTTP packet. It even deleted itself from the folder, from the original folder. Let us now take the second shot. Okay, now I can do compare. Okay, let's see what I find. I can see there is a registry value that was added, run once, and run once is done for persistence. So anything over here, that means it will run after you log in, okay? And it is executing smss.exe that is located in here, okay? There is also another key over here with a certain hash added, okay? And this one, which is also very similar to the first one. And these are modified registry values. And if I go down, I can see there is a file that was added. Notice that this file is the file that is used in the persistence, in the run once key, okay? And then the files that was deleted is the budget report file. So it has deleted itself, okay? It has modified certain files. Now we do not know whether the malware modified these files, but most probably it has interacted with some of them. And then a new folder was created. So let us investigate now just quickly. If I go to the, if I open the registry, So if I go to, let's go to this one, software. So HK current user, software, and then I find this is a key, okay? And notice that this number is the same number used for run once, 126.484.30. So now if I go to software, Microsoft, Windows, current version, run once, I can see the same number over here as a value, and I can see it points to this. Let us check now this folder, and if I go to this folder, the folder exists but nothing in here. Most probably it is hidden. Okay, most probably it is hidden. So if I go to my CMD, for example, and I do CD here, and then I do dir H, I can see it over here. So it is hidden. Okay. So we can assume that it is dropping a file in this directory and putting it in the run once, so that it runs every time you log in, and then it performs some network traffic. As you can see, it tries to talk to a certain domain. With sending HTTP to this domain, mbaquyahcn.biz. Okay, probably it tries to download a file or download like additional second level malware, or communicate with control, command and control center. Okay, so this is Rugshot. We have even more sophisticated ways of doing dynamic analysis than this, which is to use Procmon. And I'm going to demonstrate Procmon on another system, which is Windows 10, because Procmon works there better than on my Windows 7 machine. So we will demonstrate now Procmon and Procdot, and then we will end this webinar. So Procmon is another tool developed by sysinternal. So I'm going to open it here. Open it. The beautiful thing about Procmon is it has very beautiful filtering mechanism that's so powerful. Okay. Let me stop this one to avoid any garbage events, unneeded events. Okay. What you can do now, clear, you can start process monitor, okay? run your malware. I have my malware over here. Run the malware and then stop the process monitor and then do some filtering and analysis on what is captured. Process monitor would capture everything the processes are doing, okay? Creating process, the way they interact in the network, the way they interact with the file system, the way they interact with other DLLs, the way they interact with the registry. Every single event is being captured, okay? Now, I suppose I already have them captured instead of doing it right now and waste some time since this is very slow. I have already done this previously and I have Procmon captured already. So I'm gonna open this one. This is the capture of now, this will give you all the events, not only done by your malware, but everything that was done while you are capturing. So this is why you need to turn on some filtering. And I'm going to give you a few hints on what to filter. Now, it has very sophisticated filtering mechanism. You can filter on the architecture, whether it's 32-bit, 64-bit. You can filter on the authentication ID, like if authentication ID is simply the user token, the user context. So if you have multiple contexts and different processes are running using different authentication code, you can filter out the events based on the authentication code. You can filter based on the command line that was issued by these processes. You can filter using date and time, for example. You can filter using the event class, like whether if you want to know only events related to registry, events related to file system, event related to networking. You can filter using operation, whether this operation like create a file, close a file, whether it's process create, process exit, whether it's something related to registry, close a key, create a key, delete key, open a key, and so on, whether it is related to even networking, things related to TCP connect, TCP receive, reconnect, etc., etc. So you can filter by operation. You can filter by parent ID, process names, time of the day, and so on. The user, for example, the users that are running those processes. So let us filter by our process exactly. Since we have run only our budget report file, and we should see it. Okay, this is not the budget report. This is related to the financial, the Excel. But I'm gonna copy. So I'm gonna open. This is the one. So I opened the wrong file by mistake. So let me filter now by the process. By the budget report. Now, when I filter and I add the filter, I notice that the number of events will be reduced. Now I have 16,000. Now, I am interested on even filtering more stuff. So let us filter by operation, and these are usually the most important things you need to filter. Things related to registry. So registry create key is very important, and registry set value is also very important. Things related to writing a file. Okay. Now you have to notice something. You have to be careful here. There is something called create a file. Create a file often is not used really to create a file, but to open a file. Okay. While write a file is the one you need to look for to see if it creates files. And let's see if it even create other processes. Okay, so let us filter by these. Now I have got only 52. Now let's investigate here. I found like it interacts with the anti-user.dat. This is the profile, the user profile of the desktop. And I can see it does something to the registry value advanced hidden. This is something we haven't seen in the Rookshot before. And as you can see, the value that was set is 2. So if I open the registry here, reg edit, since it's dropping a file, as we have seen, and in some temporary directory, it's trying to hide the file. And if I check the options, the file options, and I have it don't show hidden files. And then I go to the temporary file, to the app data roaming. Okay. What's happening here is every time I want to show hidden files, this registry key being 0 will prevent me. Advanced hidden being 2. So if I navigate to software, Microsoft Windows, current version, Explorer, advanced, and then I check this since it is 2. If you Google this one, you will see that no matter how many times I try to show hidden files, it will not show me hidden file. This is the reason for this is the file that was dropped in the location on the temporary directory is hidden, and that file is considered or will be run at runtime. So let me run the malware now and show you exactly what I mean by that. Okay, it has deleted itself. It made the connection, the network connection. Now, if I go to this directory, okay, I cannot see any file over here. Let me try to show hidden files. And let me, if I click apply, show hidden files. I still cannot see the hidden file. While if you remember at Windows 7, we have seen a file with the name sms.exe. So it hides itself by permanently disabling show hidden file in the registry. And then it creates this registry value, and then it changes your internet zone map, okay, to bypass proxy and to disable auto detect and so on. And then it keeps looping by adding the registry key run once. It keeps and enabling the hidden don't show hidden files. It keeps looping and repeating the same one again and again. Now, if I want to know more stuff about what was being done over here, I can extract the whole thing in CSV format and then feed it into another tool. And that tool is called ProcDot. And then it will show me a visual graph of the events. And this is the beauty of now of the third tool I'm going to talk about, which is ProcDot. So let me save this using CSV, all event using CSV. And I'm going to save it on the desktop. Okay. Okay. This is the final tool now we will look at is ProcDot. We'll open ProcDot. ProcDot is a tool that can visually show you how events are interacting in a visual graph, and it takes the input from Procmon. So it reads a Procmon file, and then it will visually draw a graph for you. So you can read the Procmon file from here. This is our log file CSV. You click the launcher. It should ask you which process you would like to visually see, since there are multiple processes generating multiple events here. Meanwhile, somebody has asked about Ghidra. Ghidra is a very helpful tool, but it's not only for malware analysis. It's one of those tools for reverse engineering. So it's as good as disassembling and debugging as well. It's very portable, and it's Java based and can work on Linux and Unix and Windows.
Okay, now it's telling me which process. I'm gonna choose budget report. Double click on it. And then refresh. Okay, as you can see here, we have like a good graph. If I zoom a little bit in, I can see it starts from here. I'm going to focus on the important things. Okay. Once we run it, it affects these registry settings in the yellow. Okay, zone map, as we have seen. Okay. And what it does, you can see the purple line here, that it renames itself, to another exe file on the roaming directory. So the file we saw in the roaming directory was actually a clone of itself. So it cloned itself in the roaming directory, and then it deleted its original file. And then we can see here the run once, okay? The run once, the auto start, the persistence. And we can see that it has even created a batch file. Unfortunately, we cannot see the content of the batch file, but I'm gonna show you how on the cloud automated sandbox, we can see the content of that. So you can see all the chain of events and investigate the entire graph. It is much more visually appealing than simply scrolling through the events in proc mode. Finally, I would like to show you how it looks like on app.ani.run. I have already uploaded my malware, and I asked it to investigate it. And here it is. And as you can see, the budget report created the .bat over here. And this is the URL that we also have seen. And this is the file that it has dropped. Each time you can see the name is changing each time. One time it's CTFmon, one time it's SMSS. So probably there is some sort of randomization. And if I open the .bat file in here, I can see that all it does is simply it deletes itself. So this is what the malware does. It copies itself to another directory, and then it creates a batch file to delete itself, and then it sits in the registry at run once. It sets a persistence key, and then it tries to communicate over the internet to download something. Since we cannot know what is being downloaded, then we cannot really discover further impacts of this malware. Anyways, so this is all for today. We have seen various tools for static analysis so far: file, thread, exe info, bentext, strings, PE Studio. We have also seen regshot, procmon, procdot. Okay. And of course, there are much more tools than these, but at least these are essentials to start putting your feet into malware analysis. So thank you very much, guys, for being here. If you have any question, you can ask here on the chat. This is my email address. If you'd like to communicate with me after the webinar, if you have any inquiry, you can communicate with me, and you can also see the recordings of this webinar and the previous ones on the listed URL. Thank you again, guys. If you have any question, please ask, and hopefully I look forward to seeing you in future episodes. Thank you, guys. Bye bye.